Let's talk about how we determine the sample size. To estimate the population proportion. Okay. Now remember that the general formula for the confidence interval for the population proportion is p bar plus minus z sub alpha over 2 times the square root of p bar times 1 minus p bar divided by n. Okay. This second term is what we call the margin of error. Okay. So the question is, what's the sample size we need? To achieve a given margin of error. Okay. So first, let E be the desired margin of error. Okay. Our goal is to be able to solve for the sample size n, right? Okay. And we do this by setting E equal to the margin of error. So z sub alpha over 2 times the square root of p bar times 1 minus p bar divided by n. Okay. Now if you solve this equation for n, you're going to come up with n equals z sub alpha over 2 all square times p bar times 1 minus p bar divided by e squared. Okay. So now, what's wrong with this formula? In this formula, we want to determine what the sample size is, right? We want to determine what the sample size is, but the formula calls for a value of the sample proportion. Okay? But how do we determine the value of the sample proportion? We need the sample size. Okay? So if you use this formula, it's kind of like going in circle, right? So we modify it, so we don't use this formula, but we modify it just a little bit, right? And so we use n equals z sub alpha over 2 square times p star times 1 minus p star divided by e squared. Okay, where p star is what's known as the planning value. Right, so it's the planning value. In other words, it's just a guess of the population proportion. Okay. Okay. So now, how do we determine the value of p star? There are three ways to determine what p star is. Okay. The first way is to use a pilot study. Okay. The second way is to use a comparable study. And then if we cannot obtain a reliable estimate using either of these methods, then we use a value of 0.5 for p star. Okay? And so once we have p star, we're going to just plug in numbers into this formula and then determine what the appropriate sample size is. Okay? So let's go ahead and do a quick example. Suppose that a study in the past, right, indicates that the proportion of students at West Georgia, right? So the proportion of West Georgia students who own a dog is 0.75. Okay? The question is, what's the sample size needed? For the 95% confidence interval for the population proportion to have a margin of error of 4%. Okay? Right. So now let's go ahead and specify what we know, right? We have a study in the past. So this is like a comparable study that gives us a p star of 0.75. Okay? We have a desired margin of error of 4%. So E is 4%, which is 0.04. And we're looking at the 95% confidence interval. Okay? So Z sub alpha over 2 in this case is going to be equal to 1.96. Okay? So let's go ahead and apply the formula. Right? The formula is N equals Z sub alpha over 2 square times P star times 1 minus P star divided by E square. Okay. So this is 1.96 square times 0.75 times 1 minus 0.75 divided by 0.04 square. If you do the math here, you get 450.19 as the answer. Again, this is the sample size, right? So we cannot have a decimal number for the answer. So you would round up to the next whole number. So you would round up to N of 451, okay? So the answer is we need a sample of 451 in order for the 95% confidence interval to have a margin of error of 4%. Okay. Okay. So now let's do a quick follow-up question. The follow-up question is, so the follow-up question is, what if there is not a past study? Okay. So if we don't have a study in the past, we're gonna use a planning value P star of 0.5, right? So if we cannot obtain a reliable estimate, we're gonna use a value of 0.5 for P star, and so n is gonna be equal to 1.96 square times 0.5 times 1 minus 0.5 divided by 0.04 square. If you do the math here, you get 600.25 as your answer. Again, we always round up, so we're gonna round this number to the next whole number. So the answer is we're gonna need 601 observations in our sample. Okay.